Question 7. What will be the final volume of a 425 ml sample of gas initially at 22 degrees Celsius and 760 millimeters mercury when the temperature is changed to 30 degrees Celsius and the pressure is decreased to 360 millimeters of mercury? So we see that we have a lot of numbers here, and we're going to make a table. First number, 425 milliliters. And we see, okay, well, that's a volume. Then 22 degrees Celsius, and the little alarm goes off and says, convert that to Kelvin. So that's what happens. Don't laugh. No, go ahead and laugh.
You will now.
You will now, yes. It's the most common mistake students make. Let's see, I didn't want to do that. I just want to write the answer because I don't have room to show everything. So that's 295. 295 Kelvin. That's the temperature column. And 760 millimeters. Say 760 and I write 706. That's quite a trick. 760 millimeters of mercury. That is pressure. So all of those go together. And then it says when the temperature is changed to 30 degrees. So the new temperature is 30.0, and then that alarm goes off in your head again. And so this should be, what, 303 Kelvin? So we're adding 273. The pressure is decreased to 360 millimeters of mercury. And we have a blank, V2. And the question's asking, what's the final volume? So that works out kind of nice. So here we have 3 different things changing: volume, temperature, and pressure. So this is, there are actually multiple ways that you could do a problem like this. You could use PV equals nRT, find the number of moles, and then find the volume using PV equals nRT again. Or we can use what's called the combined gas law. I don't know if it's from the, oh, I know. There we go. Hopefully that'll work. I'm having stylus issues. P1 V1 equals, over T1 equals P2 V2 over T2. That's called the combined gas law. That has fractions in it too. Cross multiply and get rid of the fractions, unless you're really good with algebra. Some people can look at that and rearrange it in their heads, and if you can do that, awesome. If you can't, cross multiply to get rid of the fractions. So then we end up with P1 V1 T2 equals P2 V2 T1. Without the fractions, it's easier to see how to rearrange it. We're trying to solve for V2, and so we're going to divide over here by the other things that are with V2. So the P2s cancel out, the T1s cancel out. But if we do that over there, we have to do it over here, P2, T1. And I'm sorry, that's all scribbly up there. So I'm going to copy it down here nicely. So V2 equals P1 V1 T2 over P2 T1. That part is math. That's not chemistry, that's math. But you've got to understand some math to be able to do chemistry. Now we're going to take that equation and we're going to put the numbers in. When we have the equation written out there nicely with the variables, it's much easier to go to the table where everything's organized and put the correct numbers in the correct places. So P1, we look it up in the table, 760 millimeters of mercury. Include the units. I know it's annoying. The volume is 425 milliliters. Temperature 2 is 303 Kelvin. And that is divided by pressure 2, 360 millimeters of mercury, and temperature 1, 295 Kelvin. Examine the units. Millimeters of mercury cancel, kelvins cancel. Using these sorts of gas laws, Charles' law, Boyle's law, Gay-Lussac's law, Avogadro's law, combined gas law, exactly what the units are do not matter, except for temperature must be in kelvins. We don't often use Avogadro's law with N. N has to be in moles. It cannot be in grams. But pressure and volume, as long as the units agree, they will cancel out. Now you have to do that on your calculator, and be careful because you have two numbers in the denominator. So make sure you get the same answer. 760 times 425 times 303 divided by 360 divided by 295. And I get 922. 922, I rounded that to three significant figures because everybody here is three sig figs, basically. And the unit would be milliliters. So that's kind of a messy box, but a common mistake would be to end up with, common mistake would be to end up with 8 times 10 to the 7 milliliters because you accidentally multiplied by 295 instead of dividing by 295. Any questions?